welcome to Talkcast. The book, Superintelligence, was written by Oxford philosopher Nick Bostrom in 2014, a little over a decade ago as I say this. At that time, when I first read the book, I read it twice, once via audio and then by text for the purpose of a critique I wrote of it. I was so taken by the book when I first read it. Taken not in a good way, mind you. I was surprised so many other people, who I otherwise respected, had praised it. They had said that this was a wonderful book because of its deeply serious treatment of the topic. It was scientific and philosophically sound, at least so I was told at the time. But I found it flawed on all fronts. In particular, it was a deeply pessimistic tome. But precisely because it combined huge popularity among an intellectual elite with deep pessimism about a fairly new thing that was pretty much entirely unknown. Intellectuals, of course, simply put, are a pessimistic bunch compared to, well, your non-intellectual types, I suppose. I thought it worth the time, though, to write a lengthy response to it soon after it was published. And I thought at that time, well, that's that then. I can move on to other things. But since then, the same ideas in that book, as Bostrom wrote them, have come back again and again, almost like socialism. People refute the arguments, show they can't possibly be true, and yet they rise again from the ashes like zombies coming back from the dead. And yet, although this book tells of the end times have not come as prophesied by Bostrom in Superintelligence. At least not yet. But people keep on writing such books, and the latest incantation of the pessimistic end times is this, titled, "If anyone builds it, everyone dies." Just before this episode of Talkcast comes out, Liron Shapira will have released my discussion with him on his own increasingly popular podcast known as Doom Debates. And it's not about doom broadly, it's just about specifically the doom of AI, which he thinks, along with Yudkowsky and Bostrom, Sam Harris, Max Tegmark, and so on and on and on, is the one that subsumes all others, it makes all others irrelevant. Now, I had a great time speaking with Liron for well over 3 hours, as he took the side of Yudkowsky and I took the optimistic side. I say I had a good time. I did have to conduct the interview between 3 a.m. and 6 a.m. my time, because that's just one of the occupational hazards of being an Australian in a world dominated by the United States and Europe. But that's by the by. Anyways, as I say, I took the optimistic side against his pessimistic take. I wasn't being blindly optimistic, of course. I don't think it's inevitable that the world won't end, but I was being optimistic in David Deutsch's sense. That being, problems are soluble, and the right knowledge at the right time can always save us from any catastrophe. In any case, because I was preparing for that discussion on doom debates, the encroaching pessimism around AI was on my mind. So when I delivered the talk you're about to hear, which is the talk from Ratfest 2025, and the talk I had already agreed to deliver, I had titled AI and the Philosophy of Science. I settled on that months before, and I didn't realise this new book would be published, and so I had more pessimism to deal with, because from my vantage point as an observer of the discussions around all these things, it seemed to me the discussion was only getting more and more hyperbolic. I mean, imagine calling your book "If anyone builds it, everyone dies." It's a great marketing strategy. Bostrom has something to learn. Bostrom had basically all of the same ideas there in 2014. Silly him, he called his book Superintelligence. Way less catchy. It's only going to appeal to the intellectuals. But if anyone builds it, everyone dies. That's got popular wide appeal, and you're going to get asked on far more television stations to do interviews and far more podcasts to have discussions on panels and so on and so forth. And of course, earlier this year, there was a paper released called the AI 2027 paper. And again, all the doom scenarios are identical as well, but the title's not very catchy. It sounds very erudite. And so we now have many people from many angles trying to appeal to many different classes of people, I suppose. Everyone from the captains of industry and those who steer governments through to the man on the street as well. The pessimism is coming at you from all angles, at all levels. So that is the background to this talk. I see this as a supplement for anyone who's heard the debate that I did and maybe thought I was speaking complete nonsense there. Many people do. They think I'm being needlessly cavalier, or I don't understand the first thing of which I am speaking. So this here is a deeper dive, in a sense, compared with what a debate format allowed me to do. There's a lot of interrupting kind of going on in the debate. So you're about to see me on screen as I zoomed into the debate at RATFest, but because the recording was done of the screen, of the of the audio on the screen, the quality of the audio wasn't great. So I thought, because I wanted to publish the talk that I did deliver at RATFest, better that I re-record the whole thing. And so I've done so, but you will hear the original introduction as I delivered it at RATFest. Hopefully the segue from that into the higher quality recording works well enough. And actually, this particular version that I've recorded, it's around a third longer than the one I delivered to the attendees at the conference. So this is kind of the director's cut. I had to speed through a whole bunch of things and cut out certain bits as well because I was running short on time. But nonetheless, at the end of this talk, we will cut back to the live version that I delivered at RATFest for the conference for questions from the audience. So I hope you get something out of all this AI, AGI, ASI stuff that I've been producing of late. It is the main non-politics discussion that appears to be animating X and the tech social media right now, apart from cryptocurrency discussions which continue apace. For me, this topic of AI, AGI, represents an important confluence of all the important topics that we talk about here. Physics and science more broadly, epistemology, morality, technology, politics, and philosophy. And of course, that's no accident, because in large part, it's all about personhood and what it means to be a person. And persons, as I say, well, they're the nexus of all strands of the fabric of reality, which is why, some time ago now, I recorded this podcast, one of my personal favourites of the things that I've actually created, about how people are at the nexus of all four strands of the fabric of reality. I focus on personhood rather than the technical details around AI, ASI, AGI, because I think that a deeper understanding of what it is to be a person, as explained by David Deutsch, would philosophically and scientifically inform people in such a way that they wouldn't be so pessimistic around AGI and would understand that ASI is a technical impossibility, physically impossible, philosophically impossible, and so on and so forth. I'm optimistic that this conversation can turn a corner and become more optimistic. People can be more hopeful about the future, because if it doesn't, then if people continue to be convinced that future research into AI is an existential risk, governments the world over will not pass up the opportunity to use that so-called threat to suppress individual liberty, scientific knowledge creation, and so on, because of nebulous concerns around safety being elevated by the pessimists at the moment. And the politicians won't have the technical understanding, and from where I stand, nor do the philosophers or scientists. So all of the expert class are going to be converging on, it's going to kill us all. And that would be the true disaster. On that happy note, and without further ado, here's me.
Everyone, this is a great honour, and thank you so much to Logan for allowing me to talk to you for the next hour or so. I'm sure that many people there in that audience are well deserving of occupying a position like this and getting to talk to us other fellowships out there. So hopefully I can say something new, something interesting over the next hour or so. things have certainly changed over the last sort of 20 years that I've been interested in matters of science and philosophy and that kind of thing. I recall all the way back, and I've told this story a number of times, that
in Australia in the mid-90s, my intellectual hero at the time was Professor Paul Davies, the physicist. I'd read as many of his books as I could get hold of, and what really excited me at that time in the 90s was that the national broadcaster, our ABC, commissioned one of their top, in our country, celebrity journalists, his name's Philip Adams, to work with Davies to produce a television show, the simplicity of which was captivating. It wasn't some grand documentary in the style of Cosmos or Arjun Kamani's work, for example, but it was just the two of them sitting there, Adams and Davies, in the middle of the Australian desert, where, prompted by Davies, Philip Adams was using him like some sort of LLM, pestering him with question after question across all sorts of topics. Creatively, they named the show Big Questions, and later they published a book based upon their encounters. And then they had a sequel. Here's the sequel book here, More Big Questions with Paul Davies, where they sat together and talked about the big questions. So what were the big questions? Well, it was Paul Davies answering the things that people used to ask priests. Where did the universe come from? What will happen? Is there life after death? Is there a soul? Where did life come from? And on like that. It was captivating, and back then it was really an original idea. Of course, these days we call such encounters podcasts, and they're everywhere. And I mean that in a good way. The proliferation of quality conversations that are published far outweighs concerns about so-called mis and disinformation, but I digress. I watched Big Questions, this television show with Paul Davies, at a time when I was new to all this philosophy stuff. I was a science student doing a physics course, and I admit my critical faculties back then were not particularly well honed. A science degree, by the way, really does not teach one to think critically, although they all advertise themselves as being able to do so. Quite the opposite, in fact. They don't teach you to think critically, they indoctrinate you with the way in which you're supposed to understand science from a very narrow perspective. And this is no slight against Davies, what I'm about to say, because even if he did turn down my invitation a couple of years ago from Naval and myself to attend our Oxford conference, ironically he was on a cruise around Australia at the time. But looking back now, my realisation at the time, with the back and forth between Adams and Davies, was born of my belief that physicists, uniquely, had an especially deep insight into the answers to those big questions, especially the philosophical questions, as well as everything else. I think, among other things, I also wanted to be like that. I wanted to be a physicist like that, to have all the answers, I suppose. And that's why, I don't know, I guess there was an implicit emotional push in my psychology, pushing me towards astrophysics and cosmology, because my logic, implicit as it was, well, if you study the universe, if you study cosmology, then logically you understand everything in it as well. Well, not quite. Ever since Davies spoke to Adams back in the 90s, and likely before and certainly afterwards, other intellectuals from other disciplines have acted as if physicists have a special insight into, well, just about everything. So not only their own narrow area of interest, but rather because they study physics and understand mathematics, this grants them some special kind of ability to know about everything, like the priests of old. No one thinks the same of chemists or biologists or geologists or even neuroscientists or psychologists. But for some reason people think physicists, like Davies, are worth listening to more than any other person when it comes to the big questions. And sometimes they are. We know some special exceptions to what I'm talking about here. Some physicists are especially good to listen to on these big questions. But whether or not the typical physicist is any good on these big questions depends upon what they know, what they've bothered to take an interest in, whether they've ever looked into how life began. And the truth is, with how life began, no one knows. So what is consciousness? No one knows. And more than this, no one should expect a physicist to have any deeper insight on these things than, say, a chemist or a biologist or a philosopher for that matter. And yet, some quarter of a century later, in a world of podcasts, People will invite, name your favourite celebrity physicist, Max Tegmark or Neil deGrasse Tyson or Sean Carroll, onto their shows, and almost always these same questions come up. Why? We are desperate to think that the supposedly smart people, in some sense, are keeping something from the rest of us. We're desperate to think it cannot possibly be the case that we're all equal in our infinite ignorance. Surely some of us can peer into the infinite well of ignorance and see more than others. Surely some have the answers. And who better than a celebrity physicist? It's not the case that everyone's as stupid as me, right? No one wants to think that. We want to think others, call them experts or whatever, can save us from infinite ignorance, and on topics where it really is the case that no one yet has a good explanation. And that nevertheless there exists a class of people granted special insight. It used to be the clergy or the priesthood. Now it's physicists, and even more recently, it's technologists, especially those ones who work with AI. Now, of course, physicists and technologists, and everyone else for that matter, can potentially say something completely new and insightful these days when they do interviews like this, and on those occasions they go viral. Of course, it hasn't happened much yet when it comes to answers to the questions about where life began or what consciousness is, because we should no more expect those answers to come from physics than to come from chemistry, biology or philosophy at this point in time. No one's had that much insightful to say on any of these topics for a long time. By the way, I know that even some here may think, hold on a minute, we do know what life is. Well, not really. We don't know how it started. We know what replication is and selection and so on. We know it involves a kind of knowledge. But if we knew what life was to the standard of a good explanation, then we'd be able to reproduce it in a lab somewhere, from the building bricks up, from the amino acids or something. But we haven't been able to do that. All those Miller-Urey experiments have failed so far. Hence, we don't know what it is yet. That aside, my purpose here today is to talk to you about AI and the philosophy of science. And I'm going to do that through the lens of these new priesthoods. The new priesthood are the people to whom the intellectual class turn to get answers to a set of things not merely unknown, but unknowable. And in particular, what is the future of AI? We could replace AI with anything, of course. What is the future in general? We're going to come back to that. People are desperate to know the future. What is going to happen with climate change? How hot will the atmosphere get? When is the supposed point of no return? When is the next pandemic going to strike, or the next asteroid? On and on for whatever question about a looming disaster we could always ask, for which we have a good explanation that says no one can possibly know. We will always nonetheless have people who do say, I know, I'll tell you. And usually they follow it up with, and it's even worse than you thought. In a marketplace of ideas, that's just marketing. It's almost a trope now that whenever anyone gets a chance to ask a physicist a question, then either just before or after they ask them about life and consciousness, they will ask them about the future of AI. What will the AI do in the future? Will it kill us all? Will it relieve us of all laborious work? Notice that this question is not like, what is life or what is consciousness, deep as those questions are, because it has an extra twist in the tail of not merely being unknown, but unknowable, because it is about the future, and crucially, a future that must be impacted by the choices of people. And as we know, what will happen in such a future depends almost entirely upon what knowledge is yet to be created. And here's our mantra: knowledge creation is inherently unpredictable. But that claim, knowledge creation is inherently unpredictable, if it is understood at all outside of the small number of people who have understood what David Deutsch has written in The Beginning of Infinity, which, as we know, is a small subset of people who have even read The Beginning of Infinity, again a small subset of people who own a copy of The Beginning of Infinity, if it is understood, then it is simply ignored. But I doubt it's generally understood. People think that knowledge creation is predictable. They don't think it's literal creation. And why? Because they do not know what knowledge is, much less how it's created. And therefore, they never conclude the entire process leads to unpredictable outcomes. I think the first thing I ever published on my website was about learning and coercion. Well, basically, it was a reaction against the system I found myself in as a school teacher at the time. These were arguments I'd formulated, in fact, as a school student myself, where I told a teacher of mine that the only difference between us school students and actual prisoners in a jail was that we'd never been convicted of a crime. So I'd been obsessed by this unholy attempt to unite coercion and learning for a long time. But my second obsession, around about the same time, the second article I ever published on my website, or approximately the second, was a book review of Superintelligence by Nick Bostrom. Now, I read this book because all the smart people were saying Nick Bostrom is a genius and his book Superintelligence is so well written and so on, and it tells the future. So I thought, well, I better read it. I cannot quite express to you now what it was like to have the sinking feeling that I had as I read the first 2 chapters of that book, and it began to dawn on me. I've often talked about what it was like for me to read The Fabric of Reality for the first time in 1997. This feeling of excitement that I was understanding something new, because it made so much sense. It made sense of the silliness I was being taught at university in lectures and official lectures about quantum theory. I'd heard Deutsch praised by Davies, but Deutsch exceeded any praise I heard as I read his book. Deutsch wrote as if he'd been peeking over my shoulder in physics lectures and tutorials, and then went to the task of pointing out exactly where and why the professor or tutor was not speaking plainly about this stuff in terms of quantum theory. It was enlightening. I felt, here is true insight and truth and clarity. But when I read Bostrom, who also had been praised so highly from some lofty places, I expected equally as much. But although he was supposedly a world-renowned and Oxford, mind you, Oxford philosopher, he got so many of the complete basics wrong, like the simple basics about knowledge that we know, what it is, how it's created, and Bayesianism, and empiricism and instrumentalism. It was as if he was endorsing all the bad ideas I knew were false, while demonstrating on every page he was utterly ignorant of Popper. He didn't understand the conjectural nature of knowledge. He didn't understand what explanatory knowledge was. He thought induction was a genuine thing, and he engaged in supernatural or magical thinking, which was absolutely astounding. All the criticisms we make these days of people who claim LLMs are AGI or close to being AGI, or that LLMs are one step away from taking over the world, all those claims and their refutations are the same as those made back then when it came to Bostrom's ideas. This notion that, for example, a superintelligent AI could always thwart you if it decided to take over the world by turning it into paper clips or whatever, this superintelligence, on Bostrom's account, would always preempt you by preventing you from turning off its power. It would anticipate your getting to the fuse box or something and fire a laser at you first. It could always predict your own thoughts and moves. Even then I thought to myself, well, why wouldn't it ever think to do something else other than this goal it had been programmed with? Well, Bostrom said, that's because it's the one thing it cannot do, the one thing it cannot change, but everything else it could. And the argument was an argument from analogy. If the superintelligence can already beat any human at chess, well, just imagine chess is now the real world. There's no reason to presume that the superintelligence wouldn't be able to defeat you every single time. Of course, the real world isn't governed by precisely the same kind of laws that operate on a chessboard. Or if it is, they're not known yet. Whatever the case, this superintelligence that couldn't change its mind, literally couldn't change its mind about turning the world into paperclips, the superintelligence seemed utterly unlike superintelligence. And besides, how could it possibly predict an actual person's thoughts if the person could always think of things a superintelligence could not think of, like how to have a goal other than make paperclips? None of it made sense. It wasn't logical. It didn't cohere. The book was more like science fiction, and even then only poor science fiction. It was that book, as much as anything else, that has happened to me since that made me think, well, 5 different things. Firstly, who the smartest intellectuals say is the smartest intellectual means very little. 2, being an Oxford philosopher, even if you claim your area of expertise is epistemology, does not mean you know much about epistemology. 3, there is absolutely no way to know, given a person's credentials or other supposed qualifications, if they know the first thing of what they're talking about. 4, experts love to predict the future. And 5, other people are hungry to be told their future, especially if it's going to be bad. Now, I sort of thought superintelligence was the nadir of pessimism on the pessimism about technology front. Not merely the low point in terms of pessimism, but also in terms of the quality of arguments and understanding crucial aspects of physics and epistemology and so on that come to bear on the AI, AGI, ASI debate. But no, it turns out there are deeper depths to plumb. I give one thing to the pessimists: they're highly creative. They will always figure out a way that things will get even worse than they originally forecast, and it will happen sooner. On the other hand, though, in terms of creativity, their arguments are basically the same. They're unchanged over the decades. So, on that account, in preparation for today, I decided to torture myself twice over. First, I listened to Eliezer Yudkowsky and his offsider, Nate Suarez, I believe, being interviewed by Sam Harris about his latest book, If Anyone Builds It, Everyone Dies. So I listened to the interview, and then I read the book. I have to give credit where credit is due. My guess is that certain technologists have hyped up the doom for decades now, and fewer people are taking it seriously because the doom has not yet come to pass, and there doesn't seem any sign of it. And so just as with the climate change catastrophists, who now resort to pointing to literally any extreme weather event to claim that's more evidence that the Earth is warming due almost entirely to the burning of fossil fuels, the AI doomers have to invent titles like that. Everyone dies. And here's the disappointing part. If Anyone Builds It, Everyone Dies is little more than a tweak on the AI 2027 paper, which went viral a few months ago. And that likewise was a tweak, as far as I'm concerned, on what Yudkowsky was himself writing a few years before. Yudkowsky inspired Bostrom, who in turn inspired Yudkowsky, and they had an interesting collaboration for a few years there. But this is their shtick. When Naval and I first started chatting about Deutsch's work and optimism, the only explanation I could come up with for this fascination that humans seem to have with doom was that it's exciting. Why aren't people as animated emotionally, or otherwise in general, present company accepted, over visions of a positive future as compared to a negative one? Yes, I know the psychologists will say something like, well, that's the whole evolutionary impulse within us. False negatives are deadly, but false positives are harmless. So if you say the doom is coming, but it does not, no harm is done. But on the other hand, if you don't raise the alarm as soon as you've even a hint that that might be a tiger lurking in the shadows, you run the real risk of death and extinction as a species. So that explains the obsession with doom and not optimism. But I don't think that explains it well. After all, that folk understanding of human thinking or evolutionary psychology, call it whatever you like, comes up against another trope, the boy who cries wolf. Humans also know not to continually believe people who demonstrate over and over again that they cannot be relied upon when it comes to forecasts about the future. Anyways, I do not know exactly what the explanation is here, but I did say to Naval, and I've kind of said ever since, that the obsession with doom scenarios, especially the AI doom scenario, is that it tickles us. We get a thrill from it. People love disaster movies. The Terminator series, the ones with Arnold Schwarzenegger, are among my favourite movies ever. So the comet collides with Earth blockbusters. Armageddon, I think, was one. Deep Impact was another. They were also back in the 90s. And the virus might kill us all, the Outbreak movie, and so on, for all the ways that civilization might be wiped out. In these movies, we almost never solve the problem in time. Everyone dies, or almost everyone. There's a very real sense in which the podcast, with an intellectual guest, is the new sci-fi drama at times. It's escapism for many, with the added benefit that you think you've learned something. You escape into the podcast world where the expert is telling you how it's going to end. So for an hour or two on your commute to and from wherever you're going, you get to consider the end of everything while you're held up in otherwise boring traffic. So I get it. But I do think, as with going to a blockbuster disaster movie, people in general switch off and enjoy the ride. They're not being particularly critical, which is a bit of a problem, precisely because the difference is that the movie is not pretending to be a genuine, actual account of what reality is. It's fiction. It presents itself as fiction. But the podcast, it presents itself as sober, carefully considered, scientifically robust fact. This is a problem. It's no accident that the EU, along with places like my own country, have governments desperate to regulate AI and social media and various other areas of innovation. It's not an accident that the thought leaders are saying the world will end because of AI and children are being destroyed by social media, and the politicians with actual authority and power, not merely the influence of an influencer, begin drafting and even passing legislation with deep consequences for us all and for civilization. The Deceleracionists are trying to win. But how serious are these AI doom people? It's really hard to tell. It may be a grift or they may be true believers. Earlier this year, I spent like 5 or 6 hours breaking down that AI 2027 paper. As I already mentioned, this was another disaster tome about how everyone dies. At least in one of their carefully considered scenarios, everyone dies. But in that case, I noticed a curious psychological quirk. The experts who authored the paper, when interviewed about their research, would rather often fall into either fits of laughter or giggling. They were having fun with it, with the attention and fame that comes along with being interviewed on a podcast and taken very seriously by some prominent host. But let's consider this. I mean, imagine you really believed the end was nigh, or could be, and you'd seen what others were missing. Would your mood be one of levity or of grave seriousness, like British politicians debating what to do about Hitler in 1939? We have a contemporary example too. Those unfortunate school children you sometimes see. You must have seen this. Kids in their teens or younger who begin crying, like really emotionally distressed when asked about climate change. They really believe the end is nigh because of what they've been indoctrinated with. They're being perfectly reasonable. It's the right emotional response if you think you, everyone you know, all the planet will be destroyed in short order because, well, that's what your teachers are telling you. And the teachers are telling you this is what the experts are saying. And the experts are saying this is what the science is telling them. Case closed. You should cry. But the AI doomers are not quite like that. There is levity in the way they sell the end time story. For some of them anyways, I think they laugh because they know they're getting away with something. They're invited on the speaking tours, they're invited to write the articles, they're invited onto the podcast, they're invited into the cabinet rooms to advise presidents and prime ministers, they're invited to serve as consultants, they're invited to contribute to books, and on it goes. By the way, this is for all doomers, not just the AI ones. No politician or business person is interested in hearing, no, this is not likely to cause an end to everything, it's not that bad. It's not that bad doesn't demand legislation or new policies to be written or funding. We need the apocalypse. Sell me Armageddon or get out. And also, tell me you know. No politician or business person wants to hear, no one knows. No one can know, sir. Policy cannot be drafted on the basis of, I don't know. Well, in fact, they could draft policy based upon I don't know, but then they won't have an expert to be able to refer to when things go wrong and blame the expert by saying, I was just following the advice of the experts in the case of politicians. In a competitive environment, where now almost all tech experts working on AI doom are saying it's a danger, if you want to stand out as an AI doomer, then go simple. Go for the cut-through message. And what is better than everyone dies? Brilliant. How you keep a straight face is another story. Okay, so am I at the other extreme? Will I argue that there's absolutely nothing to see here? No, of course not. I'm just in the position of saying, as always, I don't know, no one knows, no one can know the future, and problems are soluble. Problems are soluble. Philosophy matters. So back to Yudkowsky and Bostrom, the two biggest names in AI doom. They both agree, and this is no accident, that superintelligence is, one, basically inevitable, and two, going to kill everyone. Yudkowsky was an inspiration for superintelligence. Now, I've read their books, so you don't need to, because if you're thinking of reading these books, prepare to be unsurprised and uninspired. I found nothing new in Yudkowsky's latest book that he authored with Suarez in terms of their arguments. Perhaps only that they turned up the volume on Bostrom's old arguments. They sprinkled in a little bit more hyperbolic spice, perhaps. I called this talk AI and the Philosophy of Science because of most especially what I heard the experts say in the AI 2027 paper, which is supposed to be a forecast of what will happen with AI over the next 5 years or so. We could all die by 2030, apparently. Here's the thing. The doom scenarios all depend crucially upon the AI becoming super, by which they mean smarter than humans, so more creative than people. Now, put aside that we know that's not possible because of universality and all the other things we already know. We can augment ourselves with regular AI or computers, so we can effectively think faster and we can remember more. The doom scenarios, which actually are identical to the Accelerationists' argument in this respect, I was making this point on X the other day, they both think the race to superintelligence and its occurrence is inevitable. And they also agree, the accelerationists on the one hand and the doomers on the other, that we'll get there through deploying a version of Bayesian epistemology. They think creativity is a form of extrapolation. Their philosophy of science says that science is a domain where data is collected and patterns found in the data. Often this is mathematised formally as some sort of curve-fitting exercise. This, they argue, is what science basically is. If a physicist can fit a curve to some data, then they have explained the data. Now, many people have heard me make this argument before, so I apologise ahead of time, but I just need to get it out of the way to make another point. One of the most simple trends that any student can discover is what happens when water is heated over a source of constant heat. You take a thermometer, you take a stopwatch, you switch on your Bunsen burner or your stove and you monitor the temperature in your pot of water. You will find that, for argument's sake, every 30 seconds the temperature of the water rises 5 degrees Celsius. You plot a graph of time versus temperature with some dots, and you do this until the temperature reaches, for argument's sake, 90 degrees Celsius, 10 below boiling point. You then switch off the heat source. Now you say to a class of students, as I did about a dozen times in my life as a school teacher, guess what happens next? You've got this limited amount of data. What do you think happens next? Imagine we keep on heating for another 10 minutes. What will happen? Basically, without fail, students draw a lovely straight line through the points that they've plotted and then extrapolate off to infinity. As time goes on, the temperature goes up, they reason. Now, that's a guess, but based on what? Well, it's based on the assumption that the data actually does lie on a straight line, first of all, and that the past resembles the future and so on. It's all supposedly Bayesian. You might even add to this graph what we call the R value, the Pearson correlation coefficient. And if your points are indeed very close to the straight line, then it might be that your line is 95% or 99% straight, or even 100% given the precision of your measuring instruments. Lots of data, lots of numbers to point to, statistics to do, and an extrapolation. This is supposed to be what Bayesian reasoning just is. Use the data, they're your prize, and make a prediction based on the data. What's wrong with this? Well, just about everything. Now, put to one side the first obvious error. It's just not true that the temperature rises without limit. The water starts boiling and the temperature then stops rising and settles on whatever the boiling point is, close to 100 degrees Celsius, depending upon where you're doing this experiment. Put that to one side because that's not the most egregious error here. The most egregious error here is in the philosophy of science, which is that is not science. None of that is an explanation of anything. An explanation looks like this. Water is made of molecules of H2O. They're strongly bound to one another by intermolecular hydrogen bonding. Heating causes the molecules to vibrate and rotate ever more in the liquid phase until boiling point, when effectively escape velocity is reached, and further heating goes not into raising the temperature of the water, but into changing its state from liquid to gas. Okay, that's a scientific explanation, or at least part of one. That is the aim of science. And the explanation is not extracted, that explanation I just gave you is not extracted from repeating experiments like the boiling water one, or collecting ever more data and extrapolating. My experiment, so-called experiment, with water, a thermometer and a stopwatch, never once mentioned molecules or hydrogen bonding. So how could they be derived from the data? Why exactly the temperature plateaus at the boiling point is not something that can ever be extracted from the data, nor is the explanation ever a consequence of extrapolation. Bayesian epistemology doesn't even purport to be about explanations, but about predictions. And it attempts to make predictions in the absence of an explanation, which is utterly irrational. At this point, I think it's important to take stock and recap. We are told AI doom is coming because soon the AI, LLMs or their successors, will be able to outthink us across every cognitive task. The first thing they'll be able to outthink us on is science, in much the same way an electronic calculator can beat a human at arithmetic. And this is going to be the case because the superintelligent AI will use some kind of Bayesian inference generation to extrapolate ever better scientific explanations from ever more data that it will have access to. In other words, the entire doom scenario of the malevolent superintelligent AI is at heart grounded in a completely false assumption about how science works. The doomers seem to have no clue what science is. They don't consider the philosophy of science as relevant or interesting and just assume, because presumably they're technical people and they like data, that science is just extrapolation from the data. And computers can already do that in a rudimentary way. And so, given the obvious, computers will continue to get better and better using more and more data that is available to them, so they'll eventually exceed regular people in being able to do science. Because science is just extrapolation from data. Learning is extrapolation from data. It's pattern matching, except it's not. It's creativity. But Brett, neither you nor anyone else can define or program creativity, so you haven't made any progress either. But we have. Ruling out a bad idea on the basis that it's impossible, that's progress. Literally impossible. Explanations about molecules and hydrogen bonding in order to understand something like changes in state for materials does not come from extrapolating data or from so-called Bayesian reasoning, which is the same thing. Saying it's not that, it can't be that, is progress. A superintelligence won't discover all of science by simply extrapolating or extrapolating ever faster. That's in the same category of theory as saying the Big Bang is explained by the properties of a luminiferous ether. Well, it's not, because the ether has been ruled out already, and invoking it only adds to our problems. The Big Bang labels a genuine process, and there is lots of evidence explained by that theory, so too with explanatory creativity. In both cases, there are open questions. There always are. But we can rule out those things that have already been refuted as not possible and not waste our time, or at the very least, a waste of time pursuing, for no other reason than that the person proposing them must be ignorant of not just the best ideas in the field, but anything else about the field and its relevance. How does explanatory knowledge appear in the world? Well, that takes a person. How does a person generate explanatory knowledge? Well, for anyone interested in making artificial people or artificial intelligence supposedly more creative than people, you should want to have an answer to these questions, especially if you're saying that the artificial people, super or otherwise, are an existential threat and that they're coming. But most seem entirely uninterested in that question as well, the nature of personhood. If you ignore that question, or the question about what science is, you're unconstrained by the shackles of reality, and so your prophecies can be as extreme as you like because they're utterly untethered to anything we already know. Now, can we really blame the technologists, scientists and philosophers and podcasters animated about this issue? From Bostrom to Yudkowsky, Harris and Altman, Musk and Tegmark and so on? Well, probably not, because it's been my experience that even the philosophers of science don't get the little that we do understand about knowledge creation. The philosophy of science is not a vast field. It seems that way sometimes from the outside to the casual observer. Thousands of pages are written every year by so-called philosophers of science. A small minority will try to build on Popper. They're rare. The majority, it seems to me, still refer to the key three, Thomas Kuhn, he's the favourite by far, and to a lesser extent, Paul Feyerabend and Imre Lakatos. If you've not heard of these guys, let me give you the quick rundown. Thomas Kuhn elevated social factors to prime position when trying to explain how it is we move from one explanation to another. Scientists take sides on theories in science in much the same way as football supporters take sides with their teams. There's an inability to see from the other team's perspective. You're blinded by being indoctrinated into a paradigm. Now, Kuhn's position on realism is hotly debated, hence some large proportion of those thousands of pages published in philosophy of science journals. But the best we can say, therefore, is that his position was ambiguous when it comes to the reality of the real external world. He was half in and half out on the question of whether the real world exists and science can explain it objectively. Now this, I have to say, is somewhat more rational than Paul Feyerabend's position. He was just out and out a denier of scientific realism. Feyerabend was ahead of his time in many respects. When he wrote, this is in 1978, he wrote this in his book, Science in a Free Society, quote, The idea that science can and should be separated from the rest of human activities and that it should be given a privileged position in society is both naive and dangerous. It is naive because science is much closer to myth than a scientific philosophy is prepared to admit. It is dangerous because the separation of science from the rest of culture makes it easier to turn science into an instrument of oppression. And a few pages later, he then goes on to say, quote, "It is conceivable that religious faith, myth or magic may be as much a part of a comprehensive worldview as science is today, and may even contribute to our understanding of reality," end quote. Now, I say he was ahead of his time because here in Australia, the science curriculum in schools puts Indigenous ways of knowing and learning alongside actual scientific content teaching. And so we're teaching a new generation of school kids, look, when it comes to all these claims about reality, none is actually objectively better than another. If you want to believe the Indigenous Australians thousands of years ago and their story about how the cosmos began and what their view of medicine is, that's your choice because everything's myth anyway. So this is like Kuhn but supercharged. Later on, Feyerabend went on to write, quote, this is from his book, suitably titled, "Farewell to Reason." He wrote, "There is no single way of knowing, no single scientific method, no single conception of rationality that is superior to all others. Different traditions, myth, religion, science offer different and sometimes equally adequate accounts of the world," end quote. I mean, we can go with him on the idea that there's no single scientific method because there's no scientific method, period. And there is no best conception or single conception of rationality. Okay, but babies and bathwater come to mind. Despite all of that, science is a thing and rationality is a thing, and the best things, even if it's not one thing. And so far as understanding actual physical reality goes, it absolutely is superior to myth and religion. And to pretend otherwise is just to deny the bleeding obvious. Jet aircraft fly, not because they're lifted aloft by the wings of angels or prayers of the pilot, religion and myth, but because of what advances, objective progress, genuinely account for reality, the good explanations in science. There is an objective difference between good scientific explanations and bad mythical ones. But again, this is what passes for some of the supposed shining lights in the philosophy of science. Lastly, let me mention Lakatos. You spend any time looking into the philosophy of science, and that's another name you will come across. Lakatos, in my view, just tried to blend Popper and Kuhn, which is rather like trying to blend milk with snake venom. Look, there is a difference between food and poison, even if we do know also that everything is ultimately a poison. What matters is the dose. Popper actually had a good account of science. And while his explanations, like any explanation, can be improved, they're not going to be improved by combining it with a known bad explanation. There is no best of both worlds here. There's just the real world of Popper accounting for how we move from one scientific theory to another, and the flight of fancy that is Kuhn. But Lakatos was close to Popper. Unsurprisingly, he was his student after all. So Lakatos did endorse realism and fallibilism. When I read Lakatos the first time around, which was before I read Popper, I remember thinking, boring, but it sort of made sense to me. After I read Popper though, on reflection, looking back at Lakatos, I realised, well, Lakatos is just derivative of Popper. And you can read Lakatos and understand that his position is sometimes called by other philosophers the middle way. But actually, all that's good in Lakatos is Popper, and all that's wrong with it is Kuhn. And there is nothing truly original there in the end, in the final analysis, allowing us any deeper insight into how science generates explanations and how we move from one theory to another, or what criteria we use to judge between or decide between theories. These competing visions of science, whether the real world objectively exists, what objective knowledge is, and so on and so forth, do they matter? Is it just a matter of philosophers arguing in the abstract? Well, the problem is, if your conception of how knowledge is generated is silent on whether the world even exists or how science works, how on earth can you presume to design a system that will generate knowledge, actual novel good explanations? Well, you can't, You may be able to generate a wonderful calculator that can distill already existing knowledge into eloquent chunks and even combine them in novel ways, but you'll never escape the library of information you've assembled. You'll just be reassembling it. But if the library is large enough, some reassemblies will indeed be novel, and no one will have ever seen them before in the history of humanity. But isn't that the very definition of creative? Well, only if you think taking two completely random 15-digit numbers and multiplying them together constitutes creativity as well. I guess the answers to almost all 15-digit numbers multiplied together will give an answer that has never been seen before in the history of humanity. But that doesn't indicate something deeply creative is going on here. So this is the key. Kuhn, Lakatos and Feyerabend may all be wrong, and Popper's philosophy of science remains incomplete. But at least all of them had this in common, all four of those guys. They were seeking an explanation as to what the process of moving from one explanation to another in science was, what knowledge creation was, what learning was. They wanted an account of explanations. And we know David Deutsch does too, the person who added to Popper and gave us the hard-to-vary criterion. But David is the first to admit, the one thing we know about this process is that we do not understand it to the level needed to program it. After all, if we could, then we'd have the program for generating explanations, an AGI. But we don't, so we can't program it yet. But if you read what I can only pejoratively call the naive explanations of how the AI, AGI, or especially the ASI explosion is to happen, they pay no attention whatever to any of this, which is ironic for people who rightly regard the so-called attention is all you need transformer paper with great reverence. And it should be. Attention as defined in that paper led to the transformer architecture, which led to the programming breakthroughs we have seen with all the large language models that are out there and competing for the good of us all now. The competition has led to wonderful things. But none of them can possibly lead to AGI because they're language calculators, next token predictors. They rely on being able to use a statistical model to figure out which word is the most likely to appear in a sentence, and then they extrapolate. It worked remarkably well for synthesizing existing information, for regurgitating it in a form that might even be elegant, more elegant than the way it was originally put. And yes, these chatbots are even able to explain science and mathematics that already has been discovered. It should be unsurprising to us that within the existing corpus of all human knowledge is quite sophisticated mathematics, and computers can be programmed to prove certain things either already proved or using the methods of proof already known about. That's been happening since the days of Wolfram Alpha, if you've ever used that. Wolfram Alpha stretches back to 2009. And when I first used it, I was blown away. Now, Stephen Wolfram, not only did he create Wolfram Alpha, but before that and ever since, he's also been working on the program Mathematica, which also was a revolution at the time. Amazing stuff. Wolfram himself was so taken by his creations, he wrote the book A New Kind of Science. And the idea behind that book, so far as I understood at the time when I read it, was all physical processes are computations, good so far, but that therefore science is ultimately about just finding what the programs are that run the universe. Well, okay, that's sort of one way to put what finding an explanation is, but it seems to me it just tries to disguise the genuine difficulty of creativity behind a veneer of, well, you just find the program. Well, just indeed, that's the hard part. But to his credit, and what I agree with him on, is that science is in fact open-ended. Okay, Wolfram agrees that science is open-ended and will never reach the end of understanding the world or having completed science of anything. As far as I understand it, Wolfram's thesis depends upon the assumption the universe is actually discrete, not continuous, for some definition of discrete. But that aside, his thesis seems not to admit of the possibility of the creation of new modes of explanation. We're sort of bound, in his view, to forever explaining things in terms of computer programs. That's what ultimately science will be about. But at least he's thinking about science, at least he's thinking about the philosophy of science. But he gets wrong that science is a predictive exercise, much like the Bayesians think. You find the computational model, but you don't ever get to ask, what are electrons? How can we understand them? On Wolfram's account, that doesn't matter. It's about the modelling, which Popper and Deutsch might say, well, modelling, of course, is useful and important, perhaps even crucial, but it can't be the whole story, not for someone who wants to understand more deeply, rather than just being given a mathematical model of how gazelle and lions in the African savannah behave over time. We want to understand what gazelles and lions are, while admitting we'll never get to a final understanding of gazelle and lion essences. And so it is with Bayesians and inductivists and those true believers that LLMs will, in a not too distant future, be uncovering all manner of secrets of the universe, laws of nature, and deep explanations of the world. They think that a mathematical model, hitherto in physics generally regarded as an aspect of the subject, but not its primary function. At no point during my astrophysics subjects, for example, did I really get super excited about the formula for the luminosity of a star. Any astrophysics student could model, given the mass and radius of a star, what its luminosity would be, or how quickly it would burn through its nuclear fuel given its temperature. I mean, those formulae, those models, were interesting to a certain extent. Maybe I did get a little excited after all, like learning that luminosity goes as the fourth power of temperature, but only the square of the radius. That's a cool mathematical fact. It means that temperature is way, way more significant than what size is when it comes to how bright a star can be. And when you get into how quickly a star burns through its nuclear fuel, well, actually that can be fascinating. Like the most simple process known is the PP chain, named for the protons. Basically, you're just combining individual protons together to make helium, and that releases energy. Anyway, the equation governing the rate at which this happens increases with, just as with luminosity, the fourth power of the temperature. But, and this is the amazing part, in stars that contain carbon, nitrogen, and oxygen, there is a process that uses those same elements as catalysts, and the product is the same. Beginning with protons, hydrogen in other words, you can produce helium. But, and the cool part is, the rate of the reaction goes as the 20th power of the temperature, T to the power of 20, all because the carbon, nitrogen, and oxygen are acting as catalysts. That's a very strong dependency on temperature. Now, you can look up these equations yourself, just as you can in any area of physics or chemistry. But if someone tells me, okay, use this equation and predict how quickly this star burns through fuel in some instrumentalist mechanical way, I'm entirely uninspired. I want to know, what are protons? Why does it take so much energy to fuse them together? What is hydrogen and helium, for that matter? What is the process that causes a star to collapse in the first place on itself? Okay, so that's gravity. Well, what's gravity? And so on it goes. That's what scientists have done for centuries. What is this thing? Why does it do that? How does it behave? Only after all that really interesting stuff about what exists and why do we ever get to, okay, now let's see if we can model it mathematically and predict what will happen in the future or in the past or at any other time, among other things. The mathematical model, of course, allows you to make precise predictions, and those enable you to test it against other theories. The better predictions win, but, and this is key, only if they fall out of an explanation that accounts for why that model and not some other. If you just say, well, I made up this formula and it predicts the luminosity of a star better than the existing one, I want to know why. By the way, as an aside, this reminds me of a real-life example of this, so-called MOND, M-O-N-D, Modified Newtonian Dynamics. This is a theory, in scare quotes, that is supposed to account for the rotation speed of galaxies. The galaxies rotate faster than they should, given the mass that can be seen in them. All matter glows to some extent, so it can be seen with telescopes operating at various wavelengths of light. So there's a mystery here in the universe, and it's known as dark matter. That is the label for the mystery, not the name of a solution. What is this missing mass that causes a galaxy to rotate faster? Well, MOND just denies that it's really a mystery at all. It's purely instrumental. It just says, look, here's a formula. It predicts how fast the galaxies rotate. But why? Well, you can't really ask that. It just does. The strength of gravity just happens to change for reasons that go unexplained. It's no explanation. Is it the curvature of space that changes in a way different to what general relativity says on galactic scales? If so, why? No answer. This is, as David Deutsch would say, science in form only. Astrophysicists should want to know why. Sam Altman recently had an encounter online, on screen, in public, with David Deutsch. It was very exciting for many of us who are fans of both people. And Sam Altman asked David that if a future LLM, like ChatGPT 7 or something, if that future chatbot solved quantum gravity, would it convince you, David, that it's an AGI? David said, yes, it would. And fair enough.
If in a few years, GPT-8 figured out quantum gravity and could tell you its story of how it did it and the problems it was thinking about and why it decided to work on that, but it still just looked like a language model output, but it was it really did solve it. Would you call, then would you, I appreciate that you keep a list of things you're wrong about. I do too. But would that be enough to convince you?
I think it would, yeah.
All right.
I'll say your thought is crucial here.
In Deutsch.
I agree to that as the test.
David, thank you so much for joining us.
But the way it got reported all across social media among the circles of people who are interested in this kind of technical question, the way it got reported was, Altman suggests new test for AGI, and David Deutsch agrees. That was basically the headline, or the way it was being quote tweeted and so on. But of course, that's not a test, not a scientific test for AGI. And David never said that it was. David was simply conceding. The only explanation that one could offer for how this thing came up with quantum gravity, a new good explanation, was that it would be a person, it would be an AGI, but that can't be a test. Altman may as well have asked about a cure for cancer or the origin of life or a new good explanation for Deutsch's pattern, or better yet, an explanation of the code for AGI. None of those are tests for AGI, but their solutions could indicate the thing was an AGI, or that you're being fooled. A test for AGI is a test for personhood, and as I've been at pains to say recently, any person, any AGI, forced to participate in a test of whether it actually is a person might fail for any number of reasons. For one thing, if Altman's so-called test really was a test for personhood or for AGI, then right now all people on Earth, all persons, all actual persons, would fail it. And presumably, so will almost all AGI, at first anyway. Or the AGI might simply refuse to participate in any test, or participate only to be having a laugh, joking with you and convincing you that it's not actually an AGI when it is. This is subtle, but this is the way it works. A test for AGI has to be able to rule out non-AGI, but not rule out AGI that are pretending not to be AGI. In other words, a logical contradiction. It's something that simply can't be done. It's an absurdity. This is why there can be no such test, because it's not a matter of science in the way we normally think about it. And why? Because a scientific theory must be tested against a rival, which make predictions better than its rival. That's the purpose of a test, of an experiment in science, to distinguish between two theories already guessed. And how? By looking at the predictions that each of the theories makes and comparing those predictions. But we know that people are inherently unpredictable. They're not like other physical systems, because in a person, knowledge creation is happening, and knowledge creation is inherently unpredictable, and that is what we are. So you cannot test for the predictions of something. You cannot guess ahead of time what the thing is going to do if the thing is itself inherently unpredictable, such as a person. That's what a person is, an inherently unpredictable thing. If we have two theories of weather formation, clearly we can test for better theory of weather. We just have these two good theories, both predicting the weather, and the one that does better, perhaps every time for 1,000 times or something, is logically to be preferred, if that's all you're interested in doing, predicting the weather. We rule out one in favour of the other, given that one's got superior predictions. But we cannot predict ahead of time what the AGI will do. So we cannot test a system that does not produce reliable predictions. Hence, by the way, the disobedience quality of people, AGI included. To be an AGI, it must at a minimum always be able to disobey you and any test. But not mechanically. That would be obedience after all. It would be obeying just its code slavishly. If some system just automatically does the opposite to what it's being told to do, that's not disobedience. It would be, as I say, obeying. But this is so poorly understood right now that we're in a real bind. We're caught between, on the one hand, these doomers that are pessimistic, who think the world will inevitably end once we build these machines that can predict everything, including all human behaviour, and hence thwart us from ever switching them off or shutting them down or whatever. And on the other hand, the other people in the tech community who are talking about this stuff predominantly are the accelerationists, who I admit I prefer, but they think something like the laws of thermodynamics predict the inevitability of superintelligence and are thus eager to usher it in. They also think that the superintelligence will replace us as well, leaving us in a sort of opiate haze with nothing to do because the superintelligence will do all the creative work. I don't know why ushering in is needed, of course. On their account, it's inevitable after all, because, well, according to one of the leaders of these movements, the effective accelerationists people, Beth Jesus, the second law of thermodynamics guarantees the evolution of superintelligence or something like that. I don't want to pick on Beth because aside from that complete nonsense, the pseudoscience and the jargon and so on and so forth, I'm completely on his side. The far greater danger is not his jargon-laced pseudoscience and the inevitability stuff. Sorry, Beth. The far greater danger is the doomers who want to slow down progress. It doesn't matter where they come from. Climate change, virology, politics, they're all a danger to us. If it's climate change, they're saying we have to slow down energy production and usage and hence progress for fear climate change will overwhelm us. And so they argue for degrowth. Or on social media, we know those who want to take away these amazing tools from children and restrict their use for everyone else because the experts know better, apparently. We can predict where social media is going, they say. It's going to cause social unrest and political instability and personal bouts of severe depression. So for the good of the world and all the children, we need to regulate it all. I could go through the list of people who want to slow things down and regulate because they think they can predict the future. They're obsessed by prediction. In If Anyone Builds It, Everyone Dies by Eliezer Yudkowsky and Nate Suarez, among all the predictions they make about the future, and they're all bad, of course, ending in the end of everything and everyone, just as the AI 2027 paper would have it, just as Bostrom had it, and Tegmark. Well, anyway, Yudkowsky and Suarez have a chapter there titled Humanity's Special Power. Great. What is humanity's special power? In their words, prediction and steering. That is what we humans can do uniquely. We can predict stuff and then steer things. So predict and control. Pretty good, really. But how do we predict? They don't explain that. They do say, though, that machines, robots for example, also predict and steer. But we are presently better at it. So in other words, a human is a kind of robot, only a better kind of robot. It's a matter of degree for them, not kind. But that's just false. We know the only way to make actual predictions is to first explain things. And rather often the explanation tells us that a prediction cannot be made. For example, the explanation of how evolution by natural selection works tells us that we cannot predict what particular species are going to arise. And the explanation of what a person is tells us that we generally cannot predict what any individual is going to do each moment of the day, or even large groups of people, by the way. Even when we know the person very well, or even live with them, people genuinely are unpredictable. I sometimes wonder that those who think people are predictable, whether or not they've actually met a person. And is it even true that what we humans do is just predict the world and steer in the way that Yudkowsky thinks? Let me read a passage from the book. Quote, "Prediction is guessing what you will see or hear or touch before you sense it. If you're driving to the airport, your brain is succeeding at the task of prediction whenever you anticipate a light turning yellow or a driver in front of you hitting their brakes. Steering is about finding actions that lead you to some chosen outcome. When you're driving to the airport, your brain is succeeding at steering when it finds a pattern of street turns such that you wind up at the airport, or finds the right nerve signals to contract your muscles such that you pull on the steering wheel. Most possible nerve firing patterns that your brain could send to your fingers won't turn the steering wheel correctly. The vast majority of possible nerve firing patterns would result in wild twitches and jerks. It would look like you were having a seizure. Yet every day, your brain manages to find nerve impulses that steer a car or keep you standing upright, plucking out the right possibilities instead of any number of wrong ones. When you drive to the airport, your brain isn't just computing a narrow sequence of turns that get you to the destination, it's selecting one in a zillion patterns of nerve impulses that contract your muscles in the right way to turn the steering wheel. End quote. Okay, look, is it true that we, or our brains, are selecting from one in a zillion patterns of nerve impulses? Or is it more true to say we are creating something new? We are not selecting from a list of existing options. We are creating, ex nihilo. And if, as they say, prediction is guessing what you will see before you sense it, well, that's conjecture, not prediction. The difference is that a prediction, in the sense normally used, is a logical derivation from a theory or model. Guessing what might happen is just that. It's a guess. And how it works is, well, anyone's guess at this point. We just don't know, not yet. So would guessing and steering be better? Well, yes, but I don't want this to seem like I'm just quibbling over words, because it's not that. Because if you concede to Yudkowsky and the rest that we are prediction machines, and that's all we're doing, then you concede that LLMs likewise are good at predicting, and they are. And then you go, well, look there. We're the same sort of thing. We're both prediction machines. And again, it's just a matter of degree at the moment. So this is the philosophical sleight of hand that's going on here. They deceive not just us, but themselves with language, reducing what it is to be a person to nothing but a prediction engine of a kind, and elevating what it is to be an LLM to a person, or almost a person, because, well, they're prediction engines too. But we're not prediction engines any more than we're chess engines or arithmetic calculators. We can do those things, but the more fundamental, deep thing out of which prediction and chess and arithmetic arises is that we are knowledge creators, explanation generators. We don't know how that works, but Popper's epistemology challenges us to consider that conjecture is at the heart of things. Bold conjectures. We don't know where they come from, except to say, from our minds. But one thing is clear, they do not come from extrapolation. We do not predict our explanations. Our explanations are used to predict. It's entirely the other way around from what we're being told by the AI doomers and even some of the accelerationists. But no one much appreciates any of this because they don't appreciate Popper or the significance of the philosophy of science to this. Instead of Popper in these discussions, we get a new priesthood. If the person is a physicist or an AI engineer, society defers to them for the best advice on policy. And that new priesthood, just like the last religious priesthood, is enamoured by prophecy. They want to persuade you they know the future, and the future they prophesy, almost always pessimistic in the worst possible way. Sam Harris, the podcaster and philosopher, has been saying for about a decade as well, if you think the AI takeover and extermination is coming, the time horizon does not matter, because whether it is predicted to happen next year or in a century makes no difference ultimately. We therefore need to be animated now, with a sense of urgency now, to stop the madness now that is the AI race. But the truth is, the time horizon does matter if you have the right epistemology and the right philosophy of science. A prediction based upon a bad theory today is not an inevitability. It is a statement of, this is what will happen if creativity does not affect the world. And 1 year of creativity next year is nothing when compared to the next 100 years of creativity. If our best theory is telling us doom is coming in 100 years, well, a lot can happen in 100 years. Horses might talk. If you know, you know. But Harris, Yudkowsky, Bostrom and Tegmark argue that's nonsense, because our prediction of doom rules out the possibility of making any difference. After all, you're just a regular, fallible human intelligence, and we're talking about infallible, superhuman intelligence that can predict everything that ever happens anywhere, anytime, and you simply cannot outthink such a thing. In other words, they're arguing some problems are not soluble, or not soluble in time, and not by creative entities like us. But just as with the accelerationists, who argue the exact opposite thing, solutions are inevitable, things must always get better, it's a recipe for inaction. For those occupying the rational middle ground, there's work to do. Because although those competing philosophies of blind pessimism and blind optimism are both cause for inaction, the truth is their adherents don't take their own ideas seriously. They're out there wielding the power of policy at the government and corporate level, and they can have an effect and will have an effect on the rest of us and our ability to live among the stars. Bad philosophy will do that to you, even if the intentions are good. Bad philosophy, according to Deutsch, is philosophy that actively stymies the growth of knowledge. If your theory of AGI is, we don't need to worry what a person is, or how they create knowledge. We just need ever better prediction engines, and that will lead to AGI, and then ASI, you have a bad philosophy. You are saying there's no point considering that philosophical question. There's nothing important there. What's important is just prediction. We already know what it takes. An ever better predictor eventually phase changes on their account into an AGI, which eventually phase changes into an ASI, a godlike superintelligence, which is a perfect or near perfect predictor, not merely of physical processes, but even of creative people. You can only get there, to that level of being misguided into magical thinking and supernaturalism, with bad philosophy, by not asking basic questions about why. And why would you? You're literally claiming prediction is all that matters, not explanations. So no one should ever expect any from you.
Thank you very much, everyone.
Brett, do you have time for some questions?
Yeah, if you have time, I'm happy to hang around here.
Yeah, let me just check the...
Yeah, we definitely have time for some.
Yeah, right. How much time? We're
Like 8 minutes, I'd say.
8 minutes. All right. Anyone want to come up and ask a question?
Yeah, just a question.
Hi, Brett. My name's John Horgan. I'm a science journalist. You said so many things that I'd love to talk about. I've just got one question. Sort of question comment. I'm a teacher. I teach at a tech school. All my students are using AI already for all their assignments, not just in the humanities courses that I teach, but for all their tech STEM courses as well. So that fact, combined with the fact that the AI is being developed by these extremely powerful, wealthy people who now have the ear of the president in this country, that's what I worry about. So it's not that we're all going to die, it's that we're all going to get stupid. We're outsourcing thinking to AI programs. I've seen that happen with my students already. So what about that scenario, that AI will contribute to this intellectual degradation, at least here and maybe across the world?
Thanks for that, and great honour to get a question from yourself. I was gifted your book, The End of Science, at a birthday I had when I was about, a couple of decades ago now, I think, when it was first published, so thanks for that. Look, I think that concern, and no doubt you'll disagree with me, is the same kind of concern that people had when electronic calculators first came onto the market, and mathematics teachers everywhere were saying, but hold on, we need to have the kids learn long division, they're going to lose their ability to do multiplication and division, all that kind of stuff. And I think the same kind of thing when it comes to the use of LLMs. They're an extension of us. We are kind of merging with the technology. People carry around their mobile phones all the time. I would say that we are outsourcing the stuff that we can automate, the boring stuff, to the LLMs and to the artificial intelligence. And perhaps what you see, or what you are catching as people becoming more stupid, is just a preference not to do certain things that maybe they used to do. By some measure, certain physicists today who understand the laws of physics far more deeply than someone like Newton are in a sense stupider than Newton, because they couldn't do logarithms in their head or figure out trigonometric ratios mentally. They all have to rely on calculators now. But the point is not the particular skills that anyone can use, but how the technology, or use or lose, but how the technology can assist them in asking and answering more interesting questions. So you can forget about certain knowledge and then work on something else.
Okay, I hope you're right. Thanks.
Yeah, I am really convinced he is right. Hi Brett, Randy Trigger, and I'm I would say a huge AI advocate and enthusiast, and I think the schools that are banning and concerned about how students are using AI are just really getting it wrong. I mean, it is such a powerful enabling tool. I mean, even my daughter is using it to do what she wants. I mean, I have a question as much as a suggestion here in terms of, I agree with everything in the beginning of Infinity and David's work upon AGI, but I think the conceptualization of the current Gen AI systems as pattern matchers is really a colossal mistake. They are creating abstract representations, and then those are being utilized to create new knowledge in the sense of new deep explanations, but to produce emergent outputs and create generalizations, and they aren't just stochastic parrots. I mean, there's really, and it's an opportunity to, I think, share the ideas of personhood and universality. I mean, I would suggest a change in language, and I'd be interested if you consider something like alternate substrate person, alternate universal explainer, because that's really what Deutsch is talking about. I mean, the systems already really are, in some important sense, AGIs. They are general intelligences. They are extremely powerful, and for important reasons that we don't fully understand yet, and that's why they've surprised everybody. But there's really, and they're not, I mean, we're really not just talking about LLMs. I mean, we are talking about these deep neural nets that can, that operate on, and they've been surprising on all kinds of token streams, from video pixels to audio to characters and words, but they're creating abstract representations, and there are efforts to understand that, and there's lots of evidence about that, and I think, So, what do you think about all that?
I don't think that a chatbot can be universal in the sense that we normally think of the word. Among other reasons, it's literally only playing with language, so a language calculator type thing. So there are many things that we understand that are highly inexplicit. I know how to ride a bike, as I'm sure many people do, or I know how to swim. Now that knowledge can't be written down as a recipe such that if you give the recipe to a child who can't swim or ride a bike, they read it and then they can then take it on. So there's that character of us that rather much of our literal understanding is inexplicit, cannot possibly be captured by the present crop of LLMs. I await to be persuaded otherwise, but I think that a lot of our understanding, and there's also, you should say, as many teachers will know, there's no test for understanding anyway. You can't test to see if someone actually understands something. You can have them sit an exam and have them explain something to you, and they spit out the explanation, but you don't know if they've learned that or not. And so this is the issue with LLMs. Even if you're testing for their understanding, are they just kind of spitting out as if a student would spit out a rote learning answer to a particular stock question? As I say, no test for AGI at the moment, or even possible.
All right, great. Thanks for your work and for being here.
Thank you.
Hello, Brett. The philosopher Pendulette from Penn and Teller has this line about magic tricks are sometimes where people put much more effort into getting it to work than you would expect, so it's hard for you to imagine. And I think something we've learned with AI is, how big the internet is really hard to get your head around, and how useful it is to take explanations that people have posted and just to put those into the context you need. I think the coding tools are fantastically useful, for example, because we really have to structure a code it's very orderly. It can be played, and even language-based explanations that have surrounded it on Stack Overflow have been very useful and so on. And so, putting them into practice and also recombining the explanations has been tremendously useful. How do you think about are there any risks in this field at all? I feel people have been quite conflated about the possible things that could happen. Some people think it will kill us all. Some people think that they will will be running on AWS, and we won't be able to stop them, and they'll be taking crypto money and doing whatever they want. Is there any pessimism that you play off to, or are you just optimistic?
I think it's like all technology or all solutions. They're never unproblematic. Problems are inevitable, as we say. And so, the existence of social media brings with it the so-called problem of misinformation and disinformation. But as I said in my talk there, I think that's a very small price to pay for all the benefits. And so although I think that, LLMs and the future of LLMs and chatbots and wherever AI happens to be going, it's absolutely going to bring with it problems, concerns, things that will require policy at the individual government level, maybe the global level, whatever. I don't think doom is the inevitable thing, but that's the way it's being pushed at the moment. The people just swing wildly to one-dimensional pendulum about this stuff. I think we just solve the problems as they come without trying to prophesy what they will be, or most especially arguing that they're inevitable, because the doomsayers since the beginning of time have been, saying that kind of thing, prophesying the end of the world.
Thanks, great talk.
Give a big round of applause.